Alright, hello everyone. So today I'm going to be doing the product rule as well as the quotient rule. I'd really love to show you guys the proof for these rules, but they're just a lot of boring algebra. But if you want to kind of see a nice intuitive explanation with images and like animations, you can go to 3 Blue 1 Brown's video, which I will link in my description. But this video is more about computing some of these derivatives. Of course, I will still tell you a little bit about why, this kind of makes sense. But again, check the description for some better animated videos on this topic. So first of all, we have the product rule. And the product rule says that if we have some function that is a product of two functions, u and v, the derivative of that function is u prime v plus v prime u. So we notice that the first one has u changing, so we have the derivative of u, but v stays constant. And then the second one has v changing, which is derivative of v, and then u staying constant. So this kind of makes sense if you think about how if two things depend on x and you multiply them, the rate of change comes from how the first one changes while the second is fixed, and then after that, how the second one changes while the first one is fixed. And you can't let them both change at the same time or you will double count. I can quickly show you how this kind of works. So if we have our function u and v, the product you can imagine as being the area, okay? So our function is really the area of u of x and v of x. If we have some dx, we shift this out by du, and there's a tiny change of dv as well. And we have another little section which is du times dv, which is so small that we don't really care about. And well, df, which is the total change, is just the change in area of our two new parts. And these two new parts are the areas given by v du plus u dv. If we divide by dx, df by dx is v du dx plus u dv dx. And that is just kind of some intuition for how that could come, but well, 3 Blue 1 Brown explains that clear if you want to go check it out. And now we can do some examples for this, but first I want to verify that this works. So I'm going to take some function that we know how to differentiate using the power rule and compare that with the results from the product rule. So for example, f of x is equal to x squared multiplied by 3x cubed. You might be saying, just combine the two, multiply them, and you can do the power rule, but I want to compare them. So with using the product rule, we have to call two functions u and v. So this is u, and this is v. If we recall, the power rule says that the derivative is u prime multiplied by v. So u prime is the derivative of u, which is 2x, multiplied by v unchanged, then plus the derivative of v, which is 9x squared, multiplied by u unchanged, which is x squared. Simplifying this, we have 6x to the fourth plus 9x to the fourth. Again, we simplify, and this is 15x to the fourth. Now, I'm going to do the same thing using the power rule. So f of x is multiplying these together, 3x to the fifth. The power rule says that the derivative is then 3 times 5, so 15x to the fourth. Well, we see that the product rule is in fact true. And let's do another example, but this time with something more complicated. Let's say f of x is equal to square root of x multiplied by sine x. So for the purposes of this exercise, I will tell you the derivative of sine x is cosine of x, but I'll make another video with a nice explanation of why this is true. We can actually see it pretty nicely. Well, how do we do this? The product rule says we need to define u and v. Remember, u prime v plus v prime u. That's how I remember it. It's pretty nice. And so we do u prime v, u prime, well, root x, what is that? That's x to the half power, right? And the derivative of x to the half is half of x to the negative 1/2, correct? To 1 over 2 square root x multiplied by sine x plus v prime u which is v prime, which is cosine x, multiplied by root x. And that is the derivative of this nasty product of two functions, and we just did that really easily. Well, that's a product rule, and it is something really nice that we use a lot. Now we move on to the quotient rule, which says that if we have some function u over v and we take its derivative, it is given by u prime v minus v prime u over v squared. So some important things: we have a minus instead of a plus like the product rule, and we have some v squared below. So this one is a bit hard to give intuition, so I won't bother. You just have to take this formula as it's given to you. But of course, you can find some YouTube videos online that hopefully can explain it better. Uh, Something you can say to remember it, you can just say u prime v minus v prime u over v squared, or you can say low d high minus high d low all over low squared. Now we want to do some examples with this, so I'm going to use sine x again. So let's say we had f of x is equal to sine x over x squared. Wow, how do you do that? Well, we use our nice quotient rule. So derivative is low d high. So x squared multiplied by the derivative of the higher function, which is cosine x, minus high d low. So sine x multiplied by d low, which is 2x, all over v squared. Note that this is not a derivative, this is just v squared. So we have x to the fourth. And let's see, can we really do much about this? Yeah, well, we can take x common. We have x cosine x minus 2 sine x over x to the fourth, which is x cosine x minus 2 sine x over x cubed. And that is an example of the quotient rule. And just before I forget about it, let's verify it again. Let's see that it's true. So we had g of x is equal to x cubed over 2x squared, and something like this. Well, the derivative is high d low. Sorry. Well, the derivative is low d high. So low d high minus high d low all over low squared, which is 4x to the fourth. And let's simplify this. Our first thing is 6x to the fourth minus 4x to the fourth over 4x to the fourth. And this is 2x to the fourth on top and 4x to the fourth below. And this just simplifies to half. Okay, let's check this with the power rule. X cubed over 2x squared is equivalent to 2 half x. So we know that the derivative is just half. So we know that the quotient rule is also correct now. And this is two more powerful rules that you can add into your arsenal when you're taking derivatives. In the next video, I'll be talking about using the chain rule. And afterwards, I'll talk about some simple applications of derivatives, and that's pretty exciting, I think. And I'll see you in the next video.